Okay, so we've got over 30 people in the room now, which is about half those who signed up. So I think we'll make a start. It's 10:05. Good morning, everybody. I've given you all the ability to talk, and I will continue to do that for those coming in. If you could, though, remain on mute for most of the time. Dan has said that he's happy to take questions as he goes along, to have more of a dialogue. So if you do have a question, then maybe just unmute yourself and ask Dan a question. I think that's fine. The session will last about an hour. So yeah, let's get going. Dan, if you just want to flick on to the next slide. So it's not moving.
Sorry, Elliot, it seems to have a bit of a freeze here.
Oh dear.
There we go.
There we go. Okay. Yeah. So this morning session is hosted by APEM, by myself as Elliot Taylor, the Divisional Director for APEM's office in Ireland. I don't know if any of you have joined these webinars before, but this is the third in a series of webinars that we've held since we opened our office here in September last year. We had a session on aerial survey in the water industry, and then most recently on our marine lab capability. So today I'm joined by my colleague Dan Cadman, who's Associate Director for Hydromorphology. Dan, I don't know if you want to say a few words about yourself.
Yeah, I'm, as you said, Associate Director for the Hydromorphology team. In the presentation, I'll just recap a little bit on what hydromorphology is and what I spend my time doing. But particularly the areas we look at are river habitat, physical habitat, problems for river restoration, downstream of reservoirs, that sort of thing, sediment as well.
Thanks, Dan. So you just move on to the next slide. So just before we get stuck into the detail of the hydromorphology, the challenges and solutions to hydromorphology in Ireland. Is the slide
having a my screen is sticking again here, Elliot. Sorry.
Okay. I don't know why we can see a kind of speaker icon as well on the screen.
Now it's back to you.
Sorry about this, folks. Just bear with
Yeah,
us.
I do apologise. There we go.
Okay, fine. Yeah.
It seems
so. For those of you who don't necessarily know APEM that well, we are originally a UK-based environmental consulting firm, now working with an office fully established in Ireland, but also in a number of other parts of the world. For example, working on offshore wind projects in the US, the one that's just been re-announced by the Biden administration at Martha's Vineyard. We're also working in Australia, Vietnam, analysing marine samples off the coast of Angola in Africa. So we work broadly, globally, and we also work from source to sea. So we have disciplines that cover terrestrial ecology in the upland, including forestry. We have a big freshwater consultancy division, both sort of physical and chemical and biological aspects of freshwater. We cover the marine environment as well, so ports and harbours and offshore wind. And for anyone who may have attended the previous webinar, we also have a biological labs where we do macroinvertebrates, phytoplankton, zooplankton, both freshwater and freshwater and marine. Dan, if you move to the next slide. Yeah, so we have offices all over the UK now, and then you'll see there we have our office down here in Cork. We now have, it says 170 staff. I think we're probably up to about 200 staff now, rapidly growing. I have 2 marine staff with me here in Ireland already, and have 2 more staff joining this beginning of next week, one terrestrial freshwater and the other freshwater staff. So that's just a little bit of an introduction to APEM as a company, but let's get to the meat of the meeting, and that is on hydromorphology issues and solutions in Ireland. So I'll hand over to Dan.
Thank you, Elliot, and thank you for everyone for taking an interest. It's really encouraging and really good turnout. What I'd say is, as Elliot has said, I'm happy for people to interject if they have a particular question. You know, I can always suggest that I'll take that at the end as well. I'm also happy for people to follow up with me on things as well, or via direct or via Elliot. So what I want to do initially in the presentation is just to outline what hydromorphology is. I don't want to presume too much, and a little bit of the legislative context around it. And it is quite a broad subject area. So I look then to different types of hydromorphology problem and the different sorts of solutions that that we can bring to bear on those. Obviously, if people have got a particular interest, again, flag it to me and I can try and go into a little bit more detail on that, because there is quite a range and I've just had to sample the sort of rough plan for my talk. So just looking at what hydromorphology is, it's the physical and hydrological characteristics of rivers, which includes the underlying processes, and that is an important point. It's about restoring those in many respects. And the sorts of pressures that you see, they're very visible usually. The alterations made to the river channels, either direct modifications of channel form, which you can see 2 examples of on the top there, the barriers and weirs, and realignment and bank protection, and changes to rates of geomorphological processes, which sometimes isn't as visible but can be just as big an impact. In particular, increased rates of sediment erosion or sediment input into the river channel, changes to the river's capacity to transport sediment as well, and resultant deposition. And, you know, 2 causes of that, excessive sediment imports there on the bottom left, and flow abstraction and impoundment, which I'll be talking about later as well. So in terms of the legislative context, it is covered by European legislation. The Water Framework Directive is the key driver for most locations, and there's a requirement for all water bodies to achieve good ecological status or potential. And I'm sure those of you who are familiar with the Framework Directive would know that hydromorphology is one of many aspects of the river channel of the river that would be covered. In many locations that are considered particularly valuable, the protected areas, then the Habitats Directive is also germane to hydromorphology problems, and those locations are mapped for area on the bottom right there. I should emphasize that's pretty much because there is a handy map. We do work across the island of Ireland, and also just to say that the Water Framework Directive and the Habitats Directive are still enacted into UK legislation as well, so they're very much the driving legislation in Northern Ireland as well as in Éire. Within the WFD, hydromorphology is only a supporting element. So it consists of three components. That is the hydrological regime, river continuity, and by continuity that is not just upstream and downstream, which is longitudinal, but also the connectivity between the river and its floodplain, and vertical movements, exchanges with groundwater as well, sort of unseen connection within the river environment. And the third aspect is morphological conditions, so river depth and width variation, the structure of substrate, and the structure of the riparian zone. So hydromorphology is this term, and I believe it was actually born with the WFD, which tries to encompass these various interactions between these three elements. But I should say that as a supporting element, alteration to these components is used to discriminate between high and good status only, and to classify water bodies as heavily modified. And it is worth a word on that, because that puts hydromorphology as slightly less important than, say, water quality in the eyes of the WFD. But insofar as unless it affects ecological receptors, you sometimes do not have to address hydromorphological problems. However, as water quality becomes tackled over, as resulting from decades really of effort to address water quality problems, then effects of hydromorphology and other issues are becoming ever more apparent and becoming higher and higher up the agenda internationally. So there's a movement obviously towards catchment-based solutions, reconnecting rivers with the riparian zone, renaturalizing the physical habitat offered by rivers, and all of those are very wide, broad-based movements internationally, well established now. So specifically within Ireland, this there is a problem here. The rivers are a large majority, well, probably about half actually, are still at moderate or less or worse status. We have until 2027 to address that. Or by 2027, the target is that all water bodies should be achieving good status. So quite a lot to do. You can see there the sort of distribution across area is sort of suggests that a lot of that work is on the east side. And when you look at the Habitats Directive, there's an awful lot of habitats that are at unfavourable conservation status, the great majority of them. So yeah, quite a lot to do. And when we look at the causes of failure, hydromorphology pressures are the third most prevalent pressure on water bodies identified as being at risk of not meeting their WFD objectives. So it is receiving a lot of attention within Ireland. That's 24%, behind agriculture and wastewater only. So significant pressures that have been cited are abnormally high siltation levels and physical modifications and barriers. So, in terms of context, it just really that should provide the legislative background, and also to emphasise that it is a problem that is going to take some time to tackle, and it's a significant problem in the island. Some of those, as I said, there's quite a wide range of problems, and I've split them into two sort of broad categories here. Basically, river design to address physical modification, and that could be done upfront as advice to developers and planners to make the most of opportunities that come from development projects. In construction, advice to make sure that construction activities are sensitive to the river environment, and is trying to address the legacy of issues that has been left by years of decades and centuries, really, of agricultural drainage and insensitive development. On the other side, in terms of the geomorphological process, it's perhaps a bit less obvious, but sediment management is incredibly important to healthy rivers. And three problems that we typically look at: assessing the effects of reservoir impoundment, and that could be for water providers, but it's also for HEP generators. Quantifying fine sediment sources, locating fine sediment sources, and sediment management at structures, which can be a problem for the environment downstream, but is also a problem for the owners and operators of those structures. And I've tried to seek out, just provide some examples of each of those bolded areas. So in terms of the skill sets required to tackle these problems, I'd say the core hydromorphology skills that that we bring to bear within APEM and within my team: hydrometry, hydrology, 1 and 2D hydraulic modelling, which we use either to understand any flood risk elements, or principally to understand habitat changes within the river channel. And you know, there are many ways we can do that. To be a little bit more detail, it sounds like from Dave Campbell this afternoon about doing so from aerial photography. Geomorphology and GIS and terrain modelling are also key skill sets that we bring to bear on these problems. We also work closely with other teams within APEM. So engineers, the remote sensing team, again, that's you'll be hearing from Dave later. Our dedicated field team, and ecology and fisheries. And I'd emphasise that key to this is to see the physical habitat and the links to the ecological receptors, because that is the end game of the WFD and indeed the Habitats Directive in a majority of designated sites. Slightly outside of APEM, but you know, needs for successful delivery of a lot of schemes, you need a partnership approach with build contractors, flood risk management, you know, particularly as integrated catchment solutions become more brought to the fore. And we also have an established link with Plymouth University for sediment sample analysis, you know, quite specialised laboratory facilities. So I'll just take in this family of problems, I can perhaps just put it to the floor just to check whether people do have a particular interest in any one of those areas. Okay, I shall carry on. So, river design to address morphological alteration is, as I say, you can deal with at the development stage, where typically we would look at sedimentation, whether there's likelihood of sedimentation, and potential improvements to physical habitat that can be gained in development projects. This one, for example, is the Saltire Brook in Manchester, where there's housing development, housing and office space being developed by the river. Obviously, there's some signature developments have made use of waterfront improvements to the waterfront environment in old docklands, etc. and you know, so it's quite a in-demand service to understand how the improvements that can be gained to the river channel here. And increasingly we find, so what we've done here, for example, is hydraulic modelling to investigate channel realignments and the capability of the river to continue to flush sediment after it's been realigned. Increasingly, we try and embed net gain and natural capital in our thinking in these, looking at development opportunities as well. When it comes to tackling the issues of the past, I've just got a few examples here. You see big changes in plan form at the bottom left there, agricultural drainage, just arrow straight, offers very little diversity of habitat. It's essentially been diverted purely for conveyance purposes, allowing field drainage and transmission of water downstream. Urban development and barriers, so top right there, and bank reinforcement, similar legacy of interventions which have left an impoverished river environment, but also often a loss of amenity value, increased downstream flood risk as well. So it isn't only an environment and ecological problem, and can have big impacts on other stakeholders like fishery interests as well. So typically when we're looking at design for restoration, these are a shared environment. People live by the rivers, they own the land by the rivers. So there's a lot of stakeholder work involved typically in these types of projects. And you have to arrive, the first stage really is to arrive at a shared vision. That may be restoration, which we'd term a full return to a pre-disturbance state, a full naturalization. To be honest, that doesn't often happen. Usually it will be a partial return, which we'd term rehabilitation, or it can be less less ambitious still, and just remediation of particular features that could be, for example, barrier removal to allow upstream migration of eel or salmon. And this, we go through this to the design process. That goal setting is critical to achieving a solution that stakeholders can align with. Typically, it will then go through optioneering and feasibility, and this is sort of, really consistent with many engineering projects, because ultimately this is what they are. They're engineering and build projects. And after optioneering, a concept design, outline design, and detailed design stages. Then we move on to the build, and often forgotten, but something that we really look at closely is monitoring the effectiveness of the intervention. Can't be done everywhere, but APEM have involved in leading edge assessments of assessing the success of river restoration schemes, such as on the Tweed. And this is an area that is often criticised. The restoration community is often criticised for not really going back and checking whether the ecological goals have been met, often, or the process goals have been met. Typical interventions that we'd make: improving in-stream habitat, improving connectivity, trying to improve the connection with the riparian zone and riparian planting, and looking at opportunities for natural flood management. And more we're operating now at beyond reach scale. So looking at trying to envision catchments, entire catchments and river networks, and using remotely sensed data to and 2D habitat modeling to get an idea of the habitat under different flows, and then experiment with or simulate what happens, where the benefits are if we remove, for example, a barrier. Does that achieve more gain in habitat and more diversity of habitat than changes to the flow regime? And this is something that we're starting to look at, as I say, at a bigger scale now than just reaches, river reaches. I'm going to skip over this one because I think you'll get plenty of this from Dave. But we're working this. I was going to give an example of working with the remote sensing team on that. So I'll move on to
just to say, Dan, that Dave's presentation is just to Dara in Northern Ireland this afternoon. It's not a general one. Oh,
I do apologise. Okay, well, I should probably crack on anyway. If I'm to cover impacts at reservoirs, yep, and find sediment inputs. So impacts at reservoirs, perhaps less obvious, but these are changes really to both the sediment and the flow regime downstream of reservoirs, and the effects of reservoirs can be observable for hundreds of kilometers downstream. It depends really on the size of the reservoir and the tributary inputs downstream of flow and sediment. But I've got in the top right hand corner here, I've just illustrated this with this is the flow regime downstream of a major supply source in the Lake District of England, and this is a neighbour, and the lighter blue there is a neighbouring natural watercourse, and you can see big effects on the flow regime. So you get a reduction in the frequency of peak flows. You get these moderate flows are released for flood storage, and you get these abrupt transitions between very low flows and moderately high flows that just aren't seen in a natural hydrograph. And for much of the time, you also get a very, very steady flow right the way through the summer. So it's a big change to the flow regime downstream of reservoirs, and the physical impediment of the dam itself is a big change. It stops sediment transmission downstream, and you can get a variety of responses from that. The bottom right there are an image of a very degraded watercourse where you get a lot of spills and no compensation flow. So most of the time it's basically static water, and then spills will strip any of the fine sediment out of the river, leaving this very, very coarse sediment, which is not a very forgiving environment for river biota to adjust to. It's not something that you often see in the natural world. In terms of geomorphological change, you can change the entire plan form of the river. The river over decades starts to become potentially thinner, or it may downcut. And to understand those changes, you really need to understand the relative balance of sediment and the change to the sediment regime and the flow regime. It's all in the interaction. And how you mitigate for those, you can improve sediment supply to downstream reaches, so essentially gravel augmentation, and the aim being to prevent or reverse any bed armoring that's happened. You can try and replicate some basic function of the flow regime, so provide more spate flows and more targeted spate flows, and they may be targeted at particular species, salmon being a favourite, but increasingly targeted also at trying to restore geomorphological function over the long term. And where you can't address those, then physical restoration and making in-channel interventions to improve habitat may be necessary. And just give an example of a study we've undertaken here. There's the sorts of studies that we can do. This chart on what we've done here is continuous monitoring of flows and turbidity, but also continuous monitoring of bed load transport, where we've used little seismological plates, and we've inserted these into the riverbed, and that gets a continuous monitoring of bed load movement, and that's like refreshment of the bed at various grades of gravel. And you can see from this chart in the bottom, on the bottom there, that it's really only the higher flows that move the bed sediment. And by looking at that and by collecting those sorts of data, we're able to identify thresholds here, that thresholds of movement, and so target those important levels of release in rectifying the changes to the flood regime. And this particular site is a highly contentious SAC in upland England, a major source, water source for the water company. So yeah, very I'd say in the past, prior to these impact plates have had some academic uptake. I think they're very seldom used in the consultancy sector. We've had a lot of success with them. Saved an awful lot of operational difficulties and money, because formerly it would be done with repeated flow trials and observations during those trials, and you know, we've been able to save an awful lot of time and effort on behalf of the water undertaker.
Dan,
yep.
What was the name of the device you were using there? Was one of the questions.
They're impact plates.
Okay. How do they work?
Okay, so they have, well, I'm just flagging with the mouse here. These are essentially it's a seismological plate. So there is a logger in here housed within the plate. That obviously you need to seal, which you seal, bolt into a piece of stone, or in this case a breeze block, and then you place it in the river. And you have to be careful with the placement, it must be said, because they're essentially you're only sampling a small part of the river. So you need to place it where it's going to be representative of bed movement generally.
So I also say the movement of sediment around it or over the top of it, or
what happens is that when it records every time a sizable piece of sediment hits the plate.
Okay.
So it doesn't capture fine sediment. It's aimed at gravels, and you'll see that. And this is also quite a new application. But we housed two plates of different sensitivities next to one another. The aim being that we could understand whether you would strip out finer gravels and just leave the coarse gravels if we made releases of various flows. Okay, you know, as I said, not something that's been done widely, but has proved very, very revealing.
Thanks.
I'll just move on to addressing fine sediment at structures. You know, fine sediment is a real problem to the river environment. What it can tend to do is smother gravels, which are important for. Often this kind of work is driven by salmonids, so salmon, Atlantic salmon, trout, which spawn in clean gravels, but those gravels need to be well oxygenated, and there needs to be through flow for those to bring nutrients. The other main driver of this type of work is freshwater mussel, which are becoming increasingly rare and valuable, and we've done large-scale work on those in Scotland, but I'm afraid I can't share some of that with you because freshwater mussel are becoming so valuable, and Scotland is such a refuge for them that we don't even share what catchments we're working in, I'm afraid. So what we're trying to do with fine sediment, I'll give you an example here, is the sources can be manifold. So agriculture is a particular problem. Forestry, particularly after felling or during the early stages of plantation, and degraded peatland, and obviously those three are also all problems within Ireland, but we share them as well in the UK. Bank erosion as well can be an important local source, and you can get oddities such as point source. I've previously done work in with relic mine tailings, and there you get the additional problem of contaminants in the fine sediment. So in this example, we've been working for a while with one of the main water companies in England on an impoundment of theirs, which is an important source for them. It's a catch water that diverts water into one of their main reservoirs. And I would say that it was a niggle until it became suddenly became a business critical issue when the sedimentation prevented them abstracting during very low flows that we had in England in 2018. And there was a genuine concern at board level that they weren't going to get the water. Unfortunately, there was also a concern from downstream stakeholders that the release of sediment from behind the impoundment would affect a downstream fishery, and there was a protected site further downstream. You can see the degree of sedimentation here. And this sedimentation really is looking like it's caused by peatland degradation. So what we're asked to do here is to assess the volume of sediment for removal, which was done with our ADCP equipment. Essentially mapping the sediment. This is the impoundment here, and we've mapped the sedimentation all the way behind the impoundment. We needed to confirm the importance of the impoundment as a source of fine sediment to downstream reaches, and confirm the suitability of sediment for removal and nearby disposal, and design an operating regime to prevent sediment accumulation once the structure was cleared. So it was accepted that when it was that loaded with sediment, they needed to remove the sediment mechanically, but that water undertaker does not want to continue to having to do so. It's hundreds of thousands of pounds every time they do it. So to look at the source identification, a lot of different methods APEM can bring to bear on this. We've done a lot with remote sensing and diffuse pollution surveys with our field team. I'd say they actually designed the method which is used mostly in the UK, in England, certainly for diffuse pollution survey. But in this case, we went with sediment fingerprinting. As I say, we do a lot of work with that with Plymouth University. Sediment fingerprinting, we chose, there were differences in land use and geology, so that made it appropriate for sediment fingerprinting. And it gives you a really good quantitative likelihood of where the sediment is coming from. You get high precision and a robust evidence base. So the way sediment fingerprinting works is you get different compositions in different sources, and they can be different bedrock, but you also get different you're also able to differentiate between subsurface and surface sources like channel banks, and undisturbed and disturbed land, so cultivated land versus not non-cultivated land. So essentially you're using the properties, the chemical properties of the sediment, and unmixing them. So any downstream sediment source is comprised of all that's going on upstream, and each of these upstream sources has a chemical signature or a fingerprint that you're then unmixing and looking at the relative contributions. And
Dan, what's the sort of cost of doing sediment fingerprinting work?
It's like anything, Elliot. It really depends on the complexity of the study. So, for example, some of the work we're doing in Scotland, you know, it's multiple catchments, and they're looking at and they want a great deal of certainty. So we're doing seasonal sampling there, and that's, you know, that's tens and tens of K, getting up to 100K. But then, you know, in this particular case, we weren't needing that level of precision. We didn't undertake seasonal sampling, and we're talking sub 10K, so probably 5, 6, 7K, something like that.
Okay, so it can vary depending on what you really want it to do.
Yeah, it's like anything. You can't do a Rolls-Royce job every time, and it's not necessary every time. You know, it was really what results did is we achieved a good degree of separation between the sources, and confirmed that about 70% of the sediment in the protected area downstream was resulting from behind the impoundment and not from sort of other tributary sources. So it was something that it was a problem needed addressing. And we then therefore looked at channel habitat modelling, again, to understand primarily whether we'd get deposition and how frequently flushing flows would cleanse any sediment that was deposited in the downstream reach. And from doing that, we identified thresholds of deposition and flushing, which we then designed an operational regime around. And the upshot is that just the final component, we looked at sediment chemistry and we have which we have to do. Once it's removed, that sediment is a waste, and therefore it came under waste disposal legislation. It was in the end disposed of on a farmer's field, and probably to the benefit of that field. So, you know, but we did have to go through that process all in-house, except for the laboratory analysis of sediment. So ultimately, that sediment now, the sediment that was in here is now spread on this field to the benefit of that farmer, and the water company involved are operating this impoundment. They've been over the last winter and through the start of the summer. No issues reported with the fishery downstream. I think it's been a very successful study, resolved a really big problem for that water company, an operational problem for them. So, as I say, that want to leave some time for questions, and I know it's a flavour. There's a lot of other things we could have shown, but I chose those three. I hope that's been of interest, and I'll hand over the floor.
Thanks, Dan. There is a couple of questions. So the first one was from Shane McMonagle. What are the common sources of funding for natural capital projects where WFD and NFM are drivers? Do you know, in our experience?
I personally, I'm not a natural capital expert. So I could stand to be corrected on this, but I feel the way natural capital will go is it's an element of other studies. So where, for example, on the restoration study that one restoration study that we did with natural capital, that natural capital just became the way which we use to evaluate the benefits and the optioneering. That was work done for Natural England, but it could come from any really any source. So the developer may be the funder and use natural capital as the way to determine the best way forward, or it could be the regulator that uses natural capital as to determine the best way forward. But I use natural capital only as a bolt-on to other projects and a way of addressing the hydromorphology question, rather than just a pure natural capital project. If that's helpful, Shane.
And Dan, there's a question from Karen Griffin. How does APEM see their role in working with agriculture sector, where many see the rivers as a drainage function? And how would one address gravel removal that is seen as an impediment to flow and bank erosion?
Yeah, very, very difficult. And it does very much depend on the stakeholders. Where I've come across this, we are usually working for a client, so it's not often the farmers themselves. It would be a water company or an electricity provider or one of the regulatory organisations potentially, and we have worked with farmers, and it can take a lot of stakeholder consultation. I've found that they have often quite entrenched views, if it's not meant in a pejorative sense, but they see, they have very visual experience of sedimentation, and to them it causes a problem to their fields, in accelerating flooding. But what they don't often see is that by taking the sediment out, they're stopping the river adjusting, and then often all they're going to do is get sediment redepositing. I've come across, for example, in the Lake District of England, where they've widened the channel, and they dig it out, widen it, and all that's done really is mean that there is less capacity to transport sediment, and therefore you get more deposition. So they're trapped in this circle of having to clean it out every few years. Yeah. And so what I've tried to do there is to show them what the trap that they're in, so that they try and understand the process behind that sedimentation, and to see if there's a better way. And I think there's also sometimes, we can't be too idealistic about this. They often need to see a quid pro quo, and you can, in restoration projects, try and look, for example, to use, say, backwater habitats as secondary channels that may reduce the chance of flooding for their fields, or if you are going to realign the channel, to perhaps make some areas a little less prone to wetting as well, just by using it as infill. But sometimes it just is a little bit of a conflict in aims between a farmer who wants to use a riparian zone for farming and the restoration aims of, say, the regulator for achieving, say, a wetland in the riparian zone. And often that's a difficult part of the gaining a shared vision. And I think it's overstated sometimes that sometimes you don't always get a shared vision. Yeah,
but I think there's always an element of crossover and of mutual benefit, and we try and focus in that area. Another thing that we had done on a project was to actually organise some kind of exchange visits. So we took farmers from the upper catchment to the lower catchment, and they were quite shocked by what they saw in terms of the quantity of sediment that was being deposited in the lower catchment and that was coming from the upper catchment. So I think things like that help to explain the issues actually visually and practically can also assist with helping people change their minds.
Yes, in my experience, it's very much a community, and people don't want to be seen as acting against others in that community. Yeah.
Any other questions? Graham.
Yeah, Dan. Hi, Graham Thornton here. I was working in this catchment, and I kind of went in with fresh eyes as an environmental scientist, and the issues were flooding and water quality in the river, and it was very much an agricultural catchment. And my initial reaction on visiting the catchment was that it was just industrial drainage, and the design of the drains totally just about moving water as quickly as possible. After talking with the county council, who were in charge of draining some of the larger main drainage areas, they told me two things. One, that the way they were just digging out the sediments and the deep channels and just continually trying to maintain the straight drains in the same way was driven by the farmers, but also that they said that it was climate change, and kind of like my gut reaction was that it's not climate change, it's not the increase in water, in terms of you get large, heavy, more there's increased, I suppose, heavy rain, more rain over shorter periods in terms of climate change. I saw the issue just from looking at the area as a pure drainage issue. And do you think that these kind of issues in terms of river quality, what is it, drainage, or how much of it is climate change in your opinion?
I mean, I don't want to downplay climate change, but I generally tend to the view that habitat change is actually a bigger problem. If you look at the habitat change globally, it's absolutely vast. We've changed an awful lot of the terrestrial surface of the globe, and the rivers as well. And most studies that I've seen with macroinvertebrates, and we APEM has a big capability in macroinvertebrates, where we have a lot PhDs who've studied this, and usually it's where you look at flow change, going back say 10-15 years even, when we've looked at flow change and tried to thinking that was the main driver, and then try to include river habitat as a controlling variable, just to control for habitat changes, so that we could isolate the flow change, and generally found that the habitat effect is far bigger. It's a physical intervention that changes to the river habitat is a really big effect, And if you look at some of the photographs of like the land drainage ditch where it's straightened, you've got no diversity there. You know, and relative to change in flow, I think that don't want to say that it's not an important effect. It is, but it's nothing like as big as an effect as changes to physical habitat. And you know, climate change is largely operating through change in flow and temperature. And temperature, I think, is probably something that is going to become more of a focus. And trying to deal with riparian shading to try to deal with temperature increases to watercourses. But yeah, no, I'm afraid I would put physical habitat above climate change when it came to the river environment. I'll stick my neck out.
Okay, thanks Dan. Yeah, there is a tendency for people to kind of hide behind climate change as a cause for this, you know, when there could be better things that are causing it. Thanks.
Yeah.
And there's also a question whether the seismic sensor on the breeze block how is it secured in the river?
It's the weight. So you do need something fairly sizable. You do want to make sure it's not going to get scoured out downstream. Is that the concern?
Gemma, do you want to just come online and ask your question so Dan gets a bit better understanding? Gemma Gorman, you typed the question.
Yes, no, I was just wondering, was it actually secured in the river? Because if it's very active, it's going to, you're going to have the problem of it'll be washed away. And also if it's a sensitive river, you don't want to be in the riverbed causing any, like, interfering with the riverbed either. So I was just wondering, was it purely based on its own self-weight to...
It was. We have, I think you could bolt them on in situ into an existing bit of bed, but I think I would limit your choices, and it is quite important to get the right location in the channel. The other thing that I think you do have to be careful of, which I've seen more often actually, is where if you put it in a depositionary location, you may not find it again. You know, it becomes buried, and therefore it's not recording anything. You know, a realistic sample of movement. So I actually feel burial is more of an issue for these than scour, even in an active channel.
Thank you.
And Dan, there's another question from Bernie White who says, how much experience, or do we have experience of flow impacts in blanket peat catchments with brown land conversion to green land? It seems that the impacts on the flow regime happen very quickly, resulting in impacts on the ecology, which is more obvious at low flows, for example, excessive macroalgae growths.
Yeah, how much experience? So the question, how much experience do we have?
Yeah, how much experience of flow impacts in blanket peat catchments? I don't know if you want to come on and elaborate on your question if I'm not putting it correctly, Bernie.
No, you have it right there, Elliot. I'm with the local authority waters programme, so we do a lot of work in blanket peat catchments in the west of Ireland, also in the border in the southwest. But as has kind of been alluded to there in a couple of the other questions, you know, we're seeing an awful lot of land conversion for agriculture, and it might be at a very extensive scale, but it still seems to be resulting in quite a significant impact on the ecology, particularly at low flows, you know, during the 2018 drought period in particular, and even there recently in kind of early May, a few days with little rainfall, the river levels seem to fall quite quickly, and you're getting these excessive macroalgal growths in what would typically be very, very low nutrient catchments in the west of Ireland. So it just seems to have a disproportionate effect almost with a very small amount of land conversion. Now there is forestry in the catchment I'm thinking of as well, like small pockets of forestry. So that's obviously impacted on the natural blow regimes in the blanket peat itself. But it just seems to be these things affecting synergistically maybe the flow regime in the river itself.
Yeah, certainly there's a lot in that. Certainly, so in a short answer is yes, we have experience in blanket peat environments. You know, a lot of in England, Scotland, the Pennines, for example. Mostly, I would say, though, I do draw a distinction that Ireland is richer in lowland peat environments. Most of my experience has been in upland peat environments. We also here, and we have observed this. Obviously, if you getting more phosphate applied to the land for nutrients, it has that effect of you know, a radical change to what is naturally very low nutrient status. We also, I don't know if you have, but we observe in England that and Wales that there is an acidification effect on macroinvertebrate populations. A useful paper by Ian Vaughan on that, actually. I'll see if I can dig it out for you. And strangely, in the Pennines, I mean, I don't know, you may not have this, but in the Pennines we have this issue of accumulated aerial-borne pollutants from the Industrial Revolution that get released as well. I'm not aware of any studies on those, on particular effects of those on river biota, but it's definitely something that happens.
Yeah, I think the acidification effect definitely has been noted in the Wicklow area in some of our work, and further west in Connemara, in and around Letterfrack, we've noticed it ourselves in a few of our catchments. So yeah, I'd be very interested in that paper. Thank you. Yeah,
what I'll do, I'll just get one of my macroinvertebrate specialists. I've worked with hydroecology a lot, but I tend to be the hydro side of that equation. And I'll pass that on to one of my macroinvertebrate focused colleagues.
Thank you.
That's okay. Yeah. Where I'd say I think there's a lot of interest over here in trying to utilize, you know, what you're saying in that essentially there is distinguishing between the impacts of lots of pressures at once is very difficult, and it needs a lot of data to achieve it, and you don't tend to get that at the site scale. And we're trying to tackle that through looking at mixed effects statistical models using, you know, sort of national scale data sets or regional scale data sets, because we just can't get the data at site scale. It's just too long a commitment to have the statistical power to discriminate between so many different potential pressures.
Great. Thanks, Dan. Well, we're getting on towards 11, so I think we've probably taken enough time of all these busy people, unless there's any other burning questions from anybody. So we have another webinar scheduled for early August that will be on water quality, so a similar topic, water quality issues and potential solutions in the island of Ireland. I've put a web link there in the chat for where you can see details of all of our forthcoming and indeed past webinars where you can listen to recordings. I've also put down at the bottom of the chat my email address and phone number and Dan's email address if you would like to get in touch if you have any other questions for us. So with that, I'll say thank you very much to you all for attending, excellent attendance, and hopefully see some of you next time. And thanks to you, Dan, for your presentation.
Thank you, Elliot. Not at all. It's been really, really good. Good morning. Thanks a lot for everybody too being so, you know, so interested.
Yeah. Great. Okay. Thanks, everybody. Take care. Bye-bye.